Have you ever wondered how object-oriented programming, or as the cool kids call it, OOP, functions? Well, today we're diving deep into the world of OOP and its four fundamental principles: encapsulation, inheritance, abstraction, and polymorphism. Imagine a world where each entity, whether it's a car, a person, or a bank account, is an object. In OOP, that's exactly how it works. These objects contain data and the operations that can interact with the data. This is the principle of encapsulation. It's like a capsule, containing everything an object needs within itself. It's a protective shell that safeguards the data from the outside world. Let's consider a bank account. The account number, the balance, these are the data. The operations could be depositing or withdrawing money. Encapsulation ensures that these operations are the only ways you can interact with the balance. You can't just randomly add or subtract money without following the rules. Next in line is inheritance. In real life, you might inherit traits from your parents, like your mother's eyes or your father's knack for cooking. In OOP, inheritance works in a similar fashion. It allows new classes to be created based on existing ones. These new classes, known as child classes, inherit the properties and methods of the parent class. For example, consider a general class bird. This class might have properties like wings and beak and methods like fly and eat. Now, if we create a new class eagle, it can inherit these properties and methods from the bird class. This means, without writing any additional code, our eagle class already has wings and a beak and can fly and eat. The third principle, abstraction, is all about simplifying complexity. Imagine trying to understand how a car works in its entirety. Daunting, right? But what if we break it down? Steering, brakes, engine, each a component, each an abstraction of the car. In OOP, we create classes based on real-world entities and only expose necessary details, keeping the inner workings hidden. This makes the whole system easier to handle. Lastly, we have polymorphism, a concept that allows objects to take on many forms. A single entity can be used in multiple forms. For instance, consider the operation draw. For a circle, draw means creating a round shape. For a square, it's about 4 equal sides. The operation is the same, but the outcome changes based on the object. That's polymorphism for you. In conclusion, the principles of encapsulation, inheritance, abstraction, and polymorphism are the cornerstones of object-oriented programming. They allow for code to be modular, reusable, and scalable, fostering a more organized and efficient development process. Each principle plays a unique role, from protecting data and simplifying complexity to promoting code reuse and flexibility. So the next time you find yourself coding, remember these 4 principles and let them guide your journey through the world of OOP.